Hi everyone, in this video we are going to learn these 5 topics. That is, we will introduce the prime number and what is a composite number and what exactly the fundamental theorem of arithmetic. Then we discuss a few types of prime numbers and then we learn how to calculate the greatest common divisor of the two numbers as well as the least common multiple. Let's start with the first topic, that is introduction to the primes and the composite number. So if we have any integer that is greater than 1 and suppose that integer is represented by p, that is called as a prime if it has only two positive factors, that is 1 and p itself. On the other hand, if the number is not a prime, then it is called as the composite number. It is important to note that prime numbers are always greater than 1. The smallest prime number is 2 and that is an even prime number. Next prime number is 3 and this is odd. Next prime number 5 and so on. So only one even prime number we have, that is 2, and rest of the prime numbers are odd. Moreover, a number is called as a composite if and only if there exists an integer a such that is less than equal to n and surely a divides n. What does it mean? Suppose we need to show that 10 is composite number. So surely there exists a number a such that a divides 10. So what are the numbers that divides 10? That is the 1, 2, 5, 10. So it means the statement is true. There exists an integer a that is less than n. So that is 2 and 5, where 2 divides 10 as well as 5 divides 10. Next we have the fundamental theorem of arithmetic. It says that every integer that is greater than 1 can be written uniquely as a prime or product of two or more prime numbers, and generally we take the factor as a non-decreasing order. What does it mean? Suppose any integer that is greater than 1, suppose it is a 5. So 5 can be uniquely written as either a prime or the product of primes. So 5 is a prime number? Yes. So we can write 5 is equal to 5 and this is a unique representation. And if we talk about the 10, so 10 is not prime number. It means that is converted into 2 or a more primes. So that is written as 2 times of 5. And it is a unique representation of the 10. Now what about the 12? So 12 is breaks as 2 into 6 and 6 is further break as 2 into 3. So again we have this is as the prime factorization of the 12 and that is always unique. Make sure, do not say that 2 into 6 is the prime factorization of the 12. Fundamental theorem state that every integer can be expressed as the product of prime numbers. So here 6 is not a prime. Now what is the prime factorization of 100? So 100 is separated as 2 into 50 and 50 is further separated as 2 into 25 and 25 is further separated as 5 into 5. So we can write 100 is written as 2 square into 5 square. So this is the prime factorization of 100. Now we have another result that is used to predict whether the number is composite or a prime. So that is called as a trial division method. It says that if n is a composite number, means if it is not a prime number, then definitely it has a prime divisor that is less than equal to root of n. What does it mean? Means if it has a composite number, there is no need to check from 1 to n minus 1 number whether any one is dividing n or not. Simply you need to check, find root of n approximately value, then find corresponding prime numbers that is less than equal to root of n, and if any of the prime divides n, so then n is composite number. Let's identify for this case. Show that 101 is prime number. So what we need to do? First we will take root of n. What is the root of 101? Root of 101 is near to the 10. So I can write this is 10 point something. or I can write that is always less than equal to 11. Now, what are the prime numbers that is less than equal to 11? So, prime numbers are 2, 3, 5, 7. Do not say 9 because 9 is not the prime. After that, 11. Now, we need to check whether 2 divides 101. No. So, we can put slash here. Whether 3 divides 101. No, because it leaves the remainder 2. Whether 5 divides 101? No. Whether 7 divides 101? No. Whether 11 divides 101? No. So none of the prime is dividing 101. So we can conclude that 101 is a prime number. So there is no need to check the number from 2 to 100 whether any one of them is dividing 101 or a not. If not, we conclude it as a prime. If yes, that is a composite number. So rather than working on the 99 numbers, we just need to figure out for these 5 prime numbers. Now let's take another example. Is 147 prime? Let's check it. First we will evaluate 147 square root, that is near to the 12 point something, or we can say this is always less than equal to 30. So we need to figure out what are the prime numbers that is less than equal to 13. So prime numbers that is less than equal to 13 are 2, 3, 5, 7, 11, 13. Now check whether 2 divides 147. No. Whether 3 divides 147? Yes. It means 147 is not a prime number. In short, it is a composite number. So this is how we can apply the previous result to predict whether the number is prime number or not with the help of few prime numbers. Next, we are going to learn the special type of prime numbers. The first type is the Mersenne prime. Mersenne prime means if the prime number is of the form 2 raised to power p minus 1, where p is further a prime number. So such prime number is called as a Mersenne prime number. Like if we take the prime number 2, so what type of number we are getting by this form? So 2 raised to power 2 minus 1, that is equal to 3. So 3 is a prime number? Yes. So we call 3 is a Mersenne prime number. It means the smallest Mersenne prime number is 3. If we take the prime number as a 3, so what we have? 2 raised to power 3 minus 1, that is equal to 7. Is 7 is a prime number? Yes. So we call 7 is a Mersenne prime number. It means after 3, the next number prime 7 is the Mersenne prime number. So P is equal to 5. Next prime number we have 5. So 2 raised to power 5 minus 1, that is equal to 31. So 31 is the next Mersenne prime number. It means 2, 5, 11, 13, 17. These all are not the Mersenne prime numbers, but they are the prime numbers. For P is equal to 7, what we have? 2 raised to power 7 minus 1. That is equal to 127. So you can check by the previous result. This is a prime number. So we call it as the Mersenne prime number. Now if I take P is equal to 11. 2 raised to power 11 minus 1, this is equal to 2047. Whether this is a prime number? No. So it is not a prime number. So if it is not a prime number, then how it can be a Mersenne prime number? Note that every integer of this form is not a Mersenne prime number by taking p here as a prime. Like when we taking p as a 11, then this gives you the composite number, not a prime number. So we call a prime as a Mersenne prime number if it can be written in this form. Next type of prime number is a twin prime number. Twin prime number means if we take the pair of primes and that is differ by 2, that is called as a twin prime numbers. For example, 3, 5. The difference is 2, so we call it as the twin prime numbers. Next twin prime number is 5, 7, then 11, 13, 17, 19. After this, we are getting this twin prime number. With the evidence of this one, there is a statement that states that There are infinitely many twin prime numbers. Now this statement is basically called as a conjecture. Conjecture means the statement is assumed to be true on the basis of partial evidence. But the proof of this statement is yet not available in the literature. Next basic term we have the greatest common divisor. This is also represented by GCD. Suppose we have any two integer a and b that is not is equal to 0. Then the largest integer d that divides a and b, that is represented as the GCD of a and b. This is also called as the HCF, highest common factor. Now, what is the GCD of 24 and 36? How to find this? So, first we write the prime factorization of 24. 24 is separated as 2 into 12. 12 is further separated as 2 into 6. 6 is further separated as 2 into 3. Now, what about the 36? What is the prime factorization of 36? That is 2 into 18. 18 is separated as 2 into 9 and 9 as 3 into 3. Here we have the unique prime factorization of these two numbers. Now we can find the common divisor. Common divisor is 2, again 2 and 3. So it means GCD of 24 and 36 is 2 into 2 into 3. That is 4 into 3, that is equal to 12. So the largest integer that divides 24 and 36, that is 12. Now what is the GCD of 17 and 22? So again we do the prime factorization of this one. As the 17 is prime number, so it can be written as a prime itself, whereas 22 is written as 2 into 11. Now nothing is common in between these two ones. Do not say that it is 0, because here we can write 17 into 1 and here 2 into 11 into 1. So the common number we are getting in this case as the 1. So we call its GCD is 1. Relevant to the GCD, we have another term that is called as a relatively prime numbers. So two integers are called as the relatively prime numbers if their GCD is 1. Like in this case, 17 and 22 GCD is 1. So we call 17 and 22 are relatively prime numbers. It is not necessary that these two numbers are prime numbers. For example, if we take 4 and 9, nothing is common between 4 and 9 except 1. So it means its GCD is 1. So we can say that 4 and 9 are the relatively prime numbers. Another term we have pairwise relatively prime number. Pairwise relatively prime number means if we have more than one numbers and we need to check whether the numbers are relatively prime number in pair form. Suppose if I take 4, 9, 2. Now, whether they are pairwise relatively prime number, how to check this? First, we will take the GCD of 4 and 9, that is 1. GCD of 9 and 2, 1. Now, another pair is GCD of 2 and 4, that is 2. This is not is equal to 1. As when we are considering the pairs, if the GCD of every pair is 1, then we call it as a pairwise relatively prime numbers. But if any pair has the GCD greater than 1, then they are not called as the pairwise relatively prime numbers. Now let's discuss the properties of the greatest common divisor. The first property is, suppose we have any integer that is greater than 0, and if we write the GCD of m into a or m into b, this is always is equal to m times of GCD of a and b. What does it mean? Let's understand with the help of example. Suppose we take the number 3 into 4 and 3 into 6. What is common in between these two one? That is 3. So we can take 3 outside. Then we can calculate the GCD of 4 and 6, that is equal to 2. So 3 into 2, that is equal to 6. It means m is common here. Take m outside. After that, just calculate the GCD of these two numbers. If for any integer k naught is equal to 0 and if that k is multiplied with a and b where a and b are the different integers, in this case we take mod of k outside into GCD of these two numbers. In the previous case we consider m greater than 0. In this case we take k as any integer provided that is not is equal to 0. And here, when we are dealing with the greatest common divisor, we need to take the positive number here. For example, GCD of minus 5 into 8 and minus 5 into 12. So rather than taking a minus 5 outside, we will take the positive 5 and then calculate the GCD of 8 and 12. 8 and 12 GCD is 4. So overall GCD of these two numbers is 20. Next property we have, if the GCD of two number is equal to D and if we divide GCD with both the number A and B, means A by D and B by D. So obviously we are going to divide this number with the GCD and D by D is 1. For example, GCD of 14 and 21 is 7. Now divide this number by 7. Divide this number by 7. What we have? 14 by 7, that is 2. 21 by 7, 3. Now what is the GCD of 2 and 3? That is always 1. Basically we are dividing 7 on both sides. So GCD of 14 by 7, 21 by 7, that is equal to 7 by 7 and that is always is equal to 1. Next we have, if the GCD of A and B is 1 and the GCD of A and C is 1, then GCD of B and C is also 1. Now what does it mean? If the GCD of two number is 1, it means nothing is common between these two one except 1 and same for this one. And if we take product of B and C, again nothing is common between the product of B and C with A. For example, GCD of 5 and 6 is 1, GCD of 5 and 7 is 1. And if I multiply 6 by 7, that will be 42. Now GCD of 42 and 5 is again 1. The next we have the least common multiple, that is also called as the LCM. Now how to find the LCM of two numbers? Basically it is the smallest positive integer that is divisible by both the numbers. So we write it in this form. For example, if we need to find the LCM of these two numbers, how we can find that one? It's a very simple. We will take the highest power of each prime factorization present in both the numbers. So what is the highest prime factorization of the two? That is 2 raised to power 4. So here we take 2 raised to power 4 into highest power of 3, that is 5. So we take 3 raised to power 5 into highest power of the prime number 7, that is 7 raised to power 2. Multiply these prime numbers with their highest power together, that will give us the LCM of these two numbers. Now if the question is what is the LCM of 14 and 10? One, we can write its prime factorization and then we can take the prime's highest power. Another is we can take these two numbers together, 14 and 10. These two numbers are divisible by 2. Here we have 7 and in this case 5. Now we can take 5. This 7 is as it is because that is not divisible by 5 and 5 is divisible by 5 and we have 1. Next prime we can take it as a 7, here as a 1, 1. So the LCM of 14 and 10 is 2 into 5 into 7. Moreover, we have the relation between the GCD and the LCM of two number, that is product of two number is always is equal to the GCD of the two number into LCM of two number. For example, in this case, LCM of 14 and is equal to 2 into 5 into 7. Now, if the question is what is the GCD of 14 and 10? So that can be calculated directly with the help of this one as we have the LCM of 14 and 10 with us. So that is equal to 14 into 10 divided by LCM of these two numbers. Simplify this, 2 into 5 is 10 and here it is 2. So the GCD of 14 and 10 is equal to 2. So if any one of them is given to us, then we can find the second one.